Okay, so composition of functions. So what is a function? What's a function?
A function is a relationship between x and y over every x value. There's a different way.
Okay, so that's a definition of it. It's a recipe or it's a set of rules, right? It just tells you how to get from an input to an output. So what's a function, right? It's a recipe, it's an algorithm, one fancy word. What's an algorithm?
It's a combination of numbers.
It's a set of steps, right? It tells you how to get from A to B, whether it's baking a cake or a mathematical function, right? It tells you, in mathematics, it tells you what to do to the input. You think of it as a machine, right? You drop something in, and the machine spits something out. Okay? And the machine is just following a set of rules. So, for example, if we have a function like f of x equals 2x plus 3, what are the rules?
X
Rules, restrictions, different words. What are the rules? And by the way, there are no restrictions upon that. It's a polynomial function. What are the rules?
For every x value, there must be a different y.
No. F of x is 2x plus 3. What do you do?
We have to multiply by
double
something.
x plus 3.
Okay, and what do you do to that x value?
Double a
What do you do? Yeah. What do the rules say? There's a specific set of rules. What do they say?
Read the equation.
Function with
Okay, Daniel.
Times 2 by x and then add.
There we go.
Yeah.
Thank you.
That's what I meant. You put it in where X is.
Yeah, but you have
But you didn't say what the rules were. It'd be like asking me, I asked you, okay, how do you bake a cake? Well, okay, you just take some flour, sugar, and eggs, you mix them all together, and you throw it in the oven, and there you get a cake, right? Or actually, no, you wouldn't have even said that. You'd have said, well, it's in the box in the store, right? You just take money and there's your cake, right?
Buy the
No,
cake.
so I want to know, what are the rules for this function, right? So I wrote a specific function. What are the rules, right? You double the x value and then you add 3. So you're taking some input value x, right? So, number 1, take a number x. Actually, it doesn't have to be a number, right? But, yeah, we'll say take a number x. Take a number. So getting in line, right? Take a number. Now serving number 27. Okay, double it. Right, that's the 2x, and then add 3. Right, giving you, amazingly, 2x plus 3. Okay? Wow, I know, right? It's like, it's amazing. How about it's Math-a-Magic. Yeah, we should do Donald in Math-Magic Land. I have the DVD somewhere. Here's another function. What does this particular function say? You answer all.
Square x plus it.
You
Plus it.
You plus it. Plus it.
Plus all. Minus.
So, we're saying, number 1, take a number. Doesn't really have to be a number. It could be an expression, right? But
Take a thing.
take a number. Square it.
Yeah, I did not. You should have told me. Why didn't you tell me?
And then plus it, right? Or what we might say colloquially, add 1.
Maybe.
Plus all.
Oh, I like supple better. I like that. Yeah, plus all way better. You're right.
Okay? Now, here's how you finish writing out this profound function definition stuff. Okay. I'll give you a moment to gaze in wonder if nothing else. You've already written it down.
We have a worksheet.
What?
Yeah.
Oh, yeah, she is on the sheet. You gotta just
Is there a worksheet? Yeah.
just write it.
Oh. Well then, let's. what do you suppose f bracket g bracket x bracket bracket, which we read as f of g of x, and sometimes may be written like this. Fog. Okay? So there's an open circle there. So this means this. Okay? It's a composite, so it's not a multiplication because the dot is not solid. Right? So fog, right, is f of g of x. What does it mean?
Take gx and
Substitute it for x.
Yeah, so you work out g of x, whatever it is, and then you substitute that into f, right? The functions are simply rules, right? Tell you how to get from an input to an output. So in this situation, we are taking the function of a function. You can do that in multiple. You can do f of g of h of I of j of k of x. It doesn't matter. This is known as the composition of functions. It has the following rules. Take a number x. Perform all the rules of the function g on x. Get some output from g, right? And then apply all the rules of function f on the result. So the output of g becomes the input of x. Which means we really have to kind of pay attention to stuff like domain and range, right? That the input for f has to be a legal input for f, right? If f is a square root function, but g is returning a negative, then okay, then there's certain times that that won't work, right? Certain values of the outputs of g that won't be inputs to f, okay, or not allowed. And g of f of x, take the number x, or it doesn't have to be a number, it could be an expression, apply the rules of f to it to get its output, and then apply that, the rules of g to the output of f. So again, we have to make sure that the range of f corresponds to the domain of g, right? So that the legal outputs from f are legal inputs to g. Just something to keep in mind. Examples. Given f of x equals 2x plus 3 and g of x equals x squared plus 1. Determine f of g of 3. Okay, so what do we do?
We have to take a number x. We have to gx. We have to perform the rules of g.
We have to do g of 3, right? You're too general here. We need to be specific. So g of 3 is 3 squared plus 1, which is 10. And then what do we do?
We have to plug it into f of x.
So we're going to do now f of 10, right? Which is 23. So f of g of 3 is 23. Okay, is g of f of 3 going to be 23?
No, it's going to be different.
Probably different, right? So f of 3 is 2 times 3 plus 3, which is 9. G of 9 is 82. So g of f of 3 is 82. So they're not the same. They would be if they were inverses of each other, but they're not. So note that f of g of 3 is not equal to g of f of 3. These are not the same since the rules are not applied in the same order, right? And since the functions aren't actually inverses of each other, in which case the output would simply be the input. And okay, determine f of g of x and then use f of g of x to determine f of g of 3. What do you notice? Well, we always notice they're the same, right? They're the same.
Because that's what we always notice. And that's,
Likely.
not really. Yeah.
We haven't actually done it, so we should put a little proviso. They're likely the same. Because every time they ask us, what do you notice? They're the same. What do you notice? They're the same. Okay, so we want to do f of g of x. So what do we do for f of g of x?
Substitute gx into f.
So what's f of x say to do? Take the input.
Put it into
So 2 times. Now our input is g of x. So 2 times. Yeah, okay, we could do that. 2 times g of x, and then do what? And add 3. So the rule for f of x is you take the input. The input in this case is g of x. Okay, what's g of x?
x squared plus 1.
So now we replace g of x by x squared plus 1 because they're the same thing.
We have to do the trinomial.
And we get,
You might do this with the trinomial. Two trinomial.
Okay, so f of g.
It'd be like.
So f of g of x is 2x squared plus 5. What's f of g of 3?
2x squared plus 5.
No. It's 2 times 3 squared plus 5. Which is 23. What do you notice about...
Mr. Mott, call in, please, Mr. Mott.
Yeah, I almost went to the wrong one. Okay, so they're the same, right?
Can you erase the likely part now?
No. Determine g of f of x, because I wrote the likely first. Okay, so what's g of f of x? So it's g of, what's f of x?
2x plus 3.
2x plus 3.
So 2 squared.
What does g say to do to the input?
Square it and add 1.
So it's 2x plus 3 quantity squared plus 1, right? Which is?
Which is 4x squared plus 12x plus 9.
Going there in one fell swoop, right? So this is g of f of x, this is g of f of x, and this is g of f. And what's g of f of 3? So everywhere we see the input, so 4 times 3 squared plus 12.
36 plus 36 equals 80.
I did not influence that. I just lost it.
That was you.
What do you notice?
What's
It's
this?
the same.
They're the same.
Black magic.
I think it's better than black magic. It's Asian.
What?
Straight.
So they are, surprisingly, not the same. Not that they're not the same, they're surprisingly not the same.
So not surprisingly.
Not surprising. Given the functions h of x is equal to the root of x minus 1 and k of x equals 2x, determine h of k of x. So what do we do?
We have to take k of x, and we have to root it and minus 1.
So h of k of x is equal to what?
It's equal to square root of 2x.
2x minus 5.
Okay. So it's the root of, well, really, okay, let's do this. It's the root of k of x minus 1.
Already? Wait, what?
Just to make it, what next? You want to do the domain range or determine k of h of x?
Determine k.
Okay, let's do k of h of x. So k of h of x is, so k says take 2 times h of x, right? Which is 2 times the root of x minus 1. Now, we must determine the domain and range of h of k of x. So that's this, right? What's the domain and range of this?
Domain is that x is greater than 1.
So domain is set of all x such that x has to be greater than or equal to a half because the 2x minus 1 must be greater than or equal to 0, which means 2x is greater than or equal to 1, which means x is greater than or equal to a half. And what's the range?
Y is greater than or equal to 0.
And since this is a radical function, then it must be positive, so y is greater than or equal to 0. Determine the domain range of k of h of x. So now we're talking this.
Domain is x is greater than or equal to 1.
Yeah, it does. What
They
is x?
just grabbed it. They just grabbed it. It doesn't touch zero.
Yes, it does.
And the range.
Y is greater than or equal to 0.
Okay, and again we have a radical, so y is greater than or equal to 0. Okay, questions, comments, concerns?
He says the first side doesn't touch 0.
He's not looking close enough.
Yeah.
Go in the table of values, see if you see a 0 for y. Yes?
Yeah, I just need to put zero. It doesn't.
Sorry?
Oh, wait, it does. Okay.
How come it's greater? Because it's what's under the radical sign cannot be negative. That's the restriction on the domain. 2 in front means nothing as far as domain goes, right? We don't care. It's the radical can't be negative, right? The expression x minus 1 must be positive, which means x must be greater than or equal to 1. Actually, it mustn't be positive, it must be non-negative. There's a difference. What's the difference between positive and non-negative?
Which is zero.
0. Because what's 0?
We just said it's not 0.
No, 0 is neither positive nor negative, right? So positive means greater than 0, non-negative means 0 or greater, right? Greater than or equal to 0 is non-negative. There is a difference. It's like the difference between Z and Z plus, right?
Oh yeah, the IB notation.
Right? Z plus doesn't include 0. Z does. It's in it. Okay. Given the functions f of x is equal and g of x, determine f of g of x. Okay, what are we gonna do?
We have to take g of x and add 1. Substitute gx into x.
So it's going to be
Gx plus 1.
g of x plus 1, which is
1 over x minus 1.
1 over x minus 1 plus 1, which is
Oh, x.
Oh my.
Oh my god. That's the NPVs.
Oh, you could do that.
1 plus x. Oh, just x.
X minus 1 plus
just
y.
X over x
It's
minus
x
1.
over x.
yeah,
1 plus my god, guys, you're so stupid.
yeah,
Yes,
yeah. You good with that?
Your power is your
Would you not?
Good enough? Yeah.
NPVs.
Okay.
No. Well, I'm sorry.
You should be.
Well, you should be.
Who's sitting there going, wait, what?
Not me.
Nobody.
Okay.
This is English.
I'm gonna do this over here and I'm gonna erase it. Okay, so you can see it.
He's gonna choose.
No, it makes perfect sense.
Yeah, I know it makes perfect sense. I
Yeah.
know it makes perfect sense.
Need a common denominator, right? What's your common denominator?
1x.
Minus 1.
Oh my god, the ones cancel out.
Huh? Yeah.
Wizard, burn him!
People like wizards. They don't like wizards.
Depends if they float or not. Okay.
And it's funny because they didn't know.
Domain and range or g of f of x?
A non-term
Matter? Oh, right. And we should state what?
X cannot equal to 1.
We should state up here.
Use it in our school last year.
Okay, so we got to keep in mind that g of x is not defined if x is equal to 1, and that this expression here is also not defined if x is equal to 1. And g of f of x.
G of f equals 1 over x plus 1 minus 1. 1 over x 3.
Okay? So where we see f of x, we are replacing it with x plus 1. Okay?
So 1 over x.
And what do we get?
1 over x.
1 over x.
Where x is not equal to 0. X cannot equal to 0.
And x cannot be 0. Okay? We're going to keep in mind because we need that now for domain, domain and range.
This is the second time.
So what's a domain?
X is not 1.
It's like you.
I never said.
That was him. That was accurate.
Why did you say my name?
Construction Expo. Field trip students, please come to the main foyer immediately.
I speak now.
Field trip. And what's the range?
Y is not equal to 0. Wait, why?
I'm just writing what he's saying. It's not necessarily right. because it's actually not right. But
Yeah, why would, yeah, no, why
It's not equal to 1, never mind.
so what's y not?
Yeah, why can it equal 0?
Why not?
Y can equal 0.
Why not?
So what can't y equal?
Yeah, why is also real?
it's just not real?
Why cannot equal
Why?
Okay, think for a moment. I know it's asking a lot, but for a moment, consider if x is really, really big, which is what we're looking at here, right? Because we look for asymptotes. So if you got 1,000 over 999, what's that closer to, 0 or 1? You got 1,000,000 over 909,999. What's that pretty close to? You got 1,000,000,000 over 1,000,000,000 minus 1.
Really close.
Yeah. You got 100 billion trillion over that minus 1. You might as well be 1. You're not quite 1, but you can't be 1. Okay, and 1 over x, domain. And the range?
Y.
Oh, you.
This is easier.
Yeah, because here's.
X is on the bottom.
You and 苹果.
Okay. Yeah, there's an x on the flag. You see back my calculator.
Your face.
Okay, why not?
I know what it means.
Other notation. Oh, well, if I'd have known, I wouldn't have introduced it earlier, but.
Wow, Dan, over. Good job repeating yourself.
So f of g of x can also be written as f open circle g of x, or g of f of x. So fog or goff really is almost there. So fog. Mr. Goff. If you have him, hey, we learned about you in math today. So, if f of x, do this, do 4. You can do this. Maybe. And then you can check this. So, okay? Easy peasy. What? I got that right.